Hello, I am Saraj Shukla. Today in this video, we are intend to discuss nomenclature for coordination compounds. And for that purpose, I have taken the examples of three compounds. These three compounds are of three types. They three all are of different types. They are the general examples. So how are they, are of different kind? So you can see in this particular example, potassium having positive charge, K plus, and how many potassium over there? 2. That means this coordination sphere will have equivalent negative charge. So double plus single plus charge and 2 potassium, that means it will result in double minus charge. All right. So in this example, coordination sphere is negatively charged. Okay. In this example, the coordination sphere does not have any charge. It is a neutral. While in this particular example, let's say this is the chlorine having 4 chlorine and negative charge. So as a result, this coordination sphere, platinum NH3 6, will have 4 positive charge. So the three examples are different. In this example, the coordination sphere is negatively charged. In this example, the coordination sphere is neutral. And in this example, the coordination sphere having positive charge. So, we have different rules for these three examples. So let's start with the first example in which the coordination sphere is negatively charged. So this was the first example. Potassium with the positive charge, this sphere will have negative charge. Okay. So always the IUPAC naming of the coordination compound always should be from left to right. What does that mean? If you see, potassium comes first if we talk about left to right. So potassium is out of the coordination sphere. This we know as coordination sphere. Potassium is out of the coordination sphere. So potassium will be named as potassium only. Generally we'll call it potassium without any particular rule and all. Now we need to name this coordination sphere. To name the coordination sphere, we need to see ligand with their number. So here I have 6 chlorine as a ligand, and the example today I am taking are of monodentate ligand. So chlorine, if you see the naming of the ligands, there will be a table in your chapter for ligand. So chlorine is named as chlorido, and this is the 6. For the 6 we have word hexa, for the 5 we have penta, for 4 we have tetra and all. So there are 6 chlorine. We will be using hexachlorido. So here we have potassium hexachlorido. Now here comes this metal atom. What about the central metal atom? We need to see a rule. If coordination sphere is neutral, having no charge or positive charge, I repeat, if coordination sphere does not have any charge or having positive charge, no change in the name of metal atom. No change in name of metal atom. That means if that was the case where sphere has the positive charge or the neutral, then we should have written like platinum, iron and silver, whatever. But here the coordination sphere has negative charge. In that case, we will use the word 8. What will we use? We use the word 8 with the metal atom. So here we have platinum, so we'll use the word platinate. All right. In the same way like chromate, ferrate. So if the coordination sphere is negatively charged, with the metal atom we'll use the word 8. If the coordination sphere is positively charged or there is no charge, the metal atom will be named as it is. Then we have to mention the oxidation state on the central metal atom in the Roman. All right. So let's calculate the oxidation state on the platinum in this particular example. So let's see. Potassium having +1 charge, this is alkali metal, right? 2 potassium atom over here, plus platinum, let's say platinum only, we are calculating it. Yeah. Chlorine halogen, it has, as a ligand also it has -1 charge, is equals to 0. There is no charge on this, mentioned in the compound. Otherwise, if supposing there was +1 written, we must have written over +1 over here. If there was, -1 written, we should have written -1 over here. So there is no charge. I will be writing 0 over here. Let's calculate it for the platinum. You will get the value +4. Yes. So we'll be mentioning 4 over here in the Roman. So what is the name? potassium hexachloroplatinate. We may talk about many more examples. You may solve the examples of this kind in which the metal is there, then the coordination sphere is there with the negative charge. All right. We will see the next example in which there is no charge. The second example in which there is no charge on the coordination sphere. Just keep remember the word using 8 with this type of example like ferrate, platinate, aluminate, argentate, and so on. So we have taken this example. In this particular example, the coordination sphere is there and there is no charge mentioned, and this is a totally neutral. So for this naming of this type of compound, firstly we need to see the ligand. So as a ligand, we have amine group and NO2. Keep remember, NO2 is ambidentate ligand. For what are the ambidentate ligand, you need to check in your chapter. Otherwise, I will be discussing in later on in other video. So NH3 and NO2. NO2 is ambidentate ligand having different sites. So for NH3 group, we use the word amine, and for NO2 group, we use the word nitrito. All right. So amine and nitrito, these are the two words. Actually, this has a different case. You will see in the chapter. This is ambidentate ligand. There are two different cases. Here I am writing nitrito N, just telling you because the ligand is attached with the nitrogen, donating the electron pair with the nitrogen. I can write nitrito N. All right. Considering it in a -1 state, oxidation state, I will be considering -1 for the NO2 -1 charge. So now see the alphabetical order. In the alphabetical order, amine comes first, nitrito comes later on. So while naming the IUPAC name, you need to write the amine first, then the nitrito. So what will be the IUPAC name of this particular example? So firstly, we will write the ligand as we have done earlier also. So how many amine are over here? There are 3 amines. So I'll be writing tri-amine. And how many nitrito are 3. So triamine, tri-nitrito. I will be using the word N over here. You will get to know about this when you will see the ligand NO2, ambidentate ligand. And what is the metal present over here? CO, cobalt. I had already told you, if there is no charge on the coordination sphere, in this type of example, the metal atom will not have word 8. So we will not write cobaltate, we will write cobalt. Now we need to write the oxidation state of cobalt over here. So if we talk about cobalt plus 3, NO2 having -1 charge, and what about the ammonia? No charge, and then it's equal to 0. So the charge will become +3. So we'll write 3 in Romans. So the name becomes triamine, trinitrito, N cobalt 3. All right. If you don't write this N, so it is also not so wrong, but better you write the N. So the next example we have in this example, this coordination sphere is showing positive charge because the chlorine already having negative charge. So this is +4 and 4Cl-. How will we know this is a +4? Because the 4Cl- are attached over here. So this is a different type. This has the positive charge. As I have already told you, always name from left to right. So the coordination sphere will be named first. In the earlier example, we had named first the potassium. You may check over here. Here I have written potassium first, then I have named the coordination sphere. In the coordination sphere, the ligands are named first, then the metal. But in this particular example, what will we do? We will name the coordination sphere first, then we will name the ion written out of the coordination sphere, and there will be no change in the naming of the ion present out of the coordination sphere. So in the coordination sphere, what will we do? Firstly, we will name the ligand, then we will name the metal atom. And this is also positive charge, so no word 8 used with the metal. So how many ligand are over there? 6. So we'll use the word hexa. So name should be hexa. NH3 is named as amine. So hexaamine. Sorry. Hexaamine platinum. Alright, 8 word will not be used because the positive charge. Alright. then you need to put the oxidation state also with the platinum. So let's see about this coordination sphere only. If you there are two ways to calculate the oxidation number. Either you can take the entire compound, or you can take this coordination sphere. If you are taking this coordination sphere, you need to mention the charge. All right. So let's say I am calculating for platinum. All right, and ammonia is having no charge, so it will always give you +4 over here. Okay, you can apply this method also, because otherwise you may write like this: platinum and +4 charge directly can be appeared on the platinum. Otherwise you may do the simple way, like ammonia having no charge, +4, chlorine -1 is equals to 0, platinum having +4 charge. 4. All right, to calculate the oxidation number is a different topic. You may see in book, or you may see any other video. So in that way, the name is hexaamine platinum 4. So we have seen three different kind of examples. These three are of three kind and very basic and general. You may have any other examples of any other kind, but they will have several changes in their naming. Like if the ligand is bridging ligand, there will be a change. And if supposing over here this is potassium, over here this is platinum. What if platinum is over here also? That means the metal atom in the coordination sphere and out of the coordination sphere is same. This is also one kind. I am telling you what other kind you might get in your book. So if you see, this is another kind. There are some ligand which are bridging ligand and all. So there is a different kind of naming in that also. So but there are little changes in those compounds. If you see, you will get. Okay. Otherwise, I will try to cover those different cases in next video. But these three cases will help you much. You will be able to writing most of the IUPAC name in your class 12 syllabus using this particular concept, because these three are the general kind, and the other kind also can be understood with the help of this with some changes in their rule. All right, that is all for today.